Hello YouTube, this is umils03. So now we're on to lesson 31 in our discussion of the Java programming fundamentals. And ever since lesson 22, we've been building up an understanding of object-oriented programming, this idea that we can create classes, we can create data types and objects of a particular type that carry properties that we're interested in following and also have functionality associated with them that we think is important and valuable for our particular purpose. What we're going to do is we're going to continue our discussion of object-oriented programming by talking about something called inheritance. Inheritance is the idea that you could create a class in Java that basically extends or inherits all the functionality from another class. So we've already spent some time formulating a person class, and we know that a person object has particular properties, right? So we know that for a person object, we keep up with a string, which is called name, and an int, which is called age, right? And we have constructors, which which are responsible for assigning values to those instance variables according to which parameters are being passed in by the programmer. So if you only pass in a name, then we need to give a default age, but we could assign the name. If you only pass in an age, we could assign the age, but then we have to give a default name. If you don't pass in anything, you have to give default values to both of them. And then of course we have these getter methods, and we're familiar with getter methods that they're public methods. So they're available, they're accessible from outside of the class. We'd want to call them from outside of the class, but they retrieve the values of instance variables, which are typically private. And then we also just have, okay, we have a silly little static method here, which accepts no inputs. It simply returns a number. I think we mentioned that method in a previous video. And then we have setter methods, and we said that setter methods don't return anything. They simply change the value of an instance variable after an object has already been created. And then finally, we have a toString method, and we said that's a string representation of a person object. So if we ever wanted to print a person object, what would we want to see displayed on the console? And so that's what this clarifies here. It's what's defined. So what if we want to have a particular class that's similar to a person that extends all the functionality of person, but then provides some functionality of its own? So you'd be talking about a particular type of person. Maybe you'd be talking about a student, or maybe you'd be talking about a doctor. So what we're going to do is we're going to create two subclasses. We're going to create a student subclass and a doctor subclass. And both of those classes are going to inherit all of the functionality of the person class. So for a doctor object, you'll be able to get their name. You'll be able to set their age because that functionality was already specified in person, and doctor is going to inherit it because doctor and student will be subclasses of person. So what we're going to do to get started is go up to the top left in BlueJ here and press new class. We've already been creating a few classes here ever since lesson 1. We had the hello world in lesson 1, and then we created these two new classes in lesson 22, one for person and one to test it. So now what we're going to do is we're going to say student, and you can drag it wherever you want. It doesn't matter exactly where it's placed on the GUI, but you're going to go ahead and double it, and we go ahead and we have this default code. Just like when we created the person class, there was the hello world class back in lesson 1, there was this default code here. We can go ahead and delete it, and so we're just going to be starting from scratch here. But the first thing you need to do in order for the student class to take all the functionality of the person class so that for a student, you don't have to write get age all over again. You don't have to write get name all over again. If you want to inherit all that functionality and you want student to have everything that person had as far as methods and fields go, you need to write public class student extends person. And so you can go ahead and compile it. This is a perfectly valid class. And then you go ahead and close it. And now you see this relationship that BlueJ makes. So now you see the student class has an arrow, a solid arrow that points to the person class. And that means that student is a subclass of person. So that means that student is going to have all of the methods that person had. So if we want to get the name of a student, we already know how to do that because it's just going to call get name of person, and get name of person is defined to just return that name instance variable. We're going to already be able to do that in student simply by writing these two words, by writing extends person. But what we still need to do in all of our subclasses, we don't need to write the methods all over again. We could have the exact same set of methods, but what we're still going to need to do is we're going to need to have constructors. So what we're going to do is first we need to declare any instance variables that are unique to this particular subclass. So what we would do, what is an attribute that we would keep track of for a student, but maybe not for a person in general? And so I came up with one. How about their grade point average, so their GPA? And then what you're going to do is this is the only instance variable that is unique to student. So it must be declared up here. It must be declared up here at the top. And then what you're going to do is you're going to say student, and you're going to make a constructor. So at this point in the parentheses, remember what goes in the parameters for constructors, any inputs, any information that you want to feed into an object as it's being created. So what you could do is you could say string n, maybe you want to have their name, int a, maybe you want to know how old they are, and then you could have double G, and so that would represent their GPA. So here's what we're going to do. We already have functionality that assigns the name instance variable to a parameter, and then we already have code that assigns the age instance variable to a parameter too. So we already know about the keyword called this, and we said that this basically prevents ambiguity between an instance variable and a parameter, a value as a parameter that you're trying to assign to that instance variable. There's also a special keyword called super. So what super does in Java is it calls the constructor or the method of a superclass. So what I'm going to do is I'm going to write super of NA. And what this does is it goes into the superclass. So the superclass here is person. So the superclass is the class that you're extending here. So we would call student the subclass and person the superclass. So what this line of code does is it goes to the superclass and it looks for the constructor that accepts a string and an int, right? Because you can look at this, right? So super of n and a. Well, what's n? Well, according to up here, n is a string. What's a? Well, according to up here, a is an int. So what it does is it goes over to person and it says, can I find a constructor that accepts a string and then an int? Because that's what I'm being told to do. I said super of NA, n's a string, a is an int. So is there a constructor that accepts a string and an int? Oh yeah, it's this one right here. What does that constructor do? It assigns the name instance variable to the first parameter that's passed in, and the age instance variable to the second parameter that's passed in. So what it does is it's actually going to replicate that code. So by calling super of NA, you are literally assigning the name instance variable for that student object to whatever parameter was passed in, the first parameter that was passed in, and the age instance variable of that student object to the second parameter that was passed in. So it runs this code here, name equals and age equals, but the n and a here are the n and a that would be fed into this student constructor. So it calls it on the n and a that you fed in when you created that student object. And it just says name is going to be the first argument, age is going to be the second. So hopefully that's kind of clear, right? It needs to match up with the right type of constructor. You passed in a string and an int, so it looks for the constructor with a string and an int. And it says, oh, here it is. I'm just going to make name the first argument and age the second. And that's exactly what happens here. So what we would do is has the effect of assigning the student's name to n and the student's age to a. And that's all there is to it. But what about for G? So now for the other one, you're just going to say this.GPA equals G, or simply GPA equals G, as there is no ambiguity between the instance variable name and the parameter name. Okay, so you just say this.GPA equals G. It's just assigning the third instance variable, right? Because G, that's not something that's part of person, right? The person constructor can only do the first two instance variables, and then you have to manually assign the third one. So this is an example of a constructor. And then you could have another constructor that is even simpler than that. What if you don't know their GPA? Well, then at that point, you could just assign their name and age just as they're fed in. And then maybe you just give a default value for GPA. So maybe you just say this.GPA equals 3. What if you don't know their age? What if they just pass in a string? What if you just want to create a student object simply only knowing their name? Well, now what you would do is you would call you can call the constructor, you could call super of n. Okay, so you could just look at the constructor that just accepts the name. And what would it do? It would assign the name to whatever you passed in, and it would assign the age to 53. So you don't even have to have a default value of age at this point, because it's going to call the default value of age from the superclass's constructor that just accepts a string. So age is set, so name is set to n, and age is set to 53 according to the constructor from the superclass that accepts a string, just a string. Remember, just a string, not an int. So that's essentially how that works. And then you could go ahead and give them something default for GPA, maybe 3.2. And then finally, you could have another default constructor. So we don't want to beat this horse too much, but you could say super. And so what would this call? This would call the default constructor if you had no arguments. And you don't have to call that constructor. So if they don't pass in any arguments, you could decide what you're going to do. But you could go ahead and say super of Troy and 16, and then it would go ahead and set the name to Troy and the age to 16, because you're calling the constructor that accepts a string and an int with these particular values. So according to the logic from person of string name and in age, if you accept a string and an int, this assigns name to Troy and age to 16. That's all there is to it. And then you could say something like this.gpa equals 2.7. Okay, so those are constructors. And then now what we can do is we can have just one piece of functionality, one method that would be unique to our student class. So what if we want to have the student do something that the person wouldn't be able to do? So for example, what if you want to study harder and increase your GPA? So what we're going to do is we're going to have an instance method. It's going to be a void method that doesn't return anything, but it's just going to be called study harder. Okay, so it's going to be called on a particular student object because it's an instance method and not a student method. And then what we could do is we could say GPA goes up by 0.1 points or something like that. So this is an example of functionality that's only available to the subclass that the person class doesn't have. So student can do everything that person can do, but person cannot do everything that student can do. And that's sort of the architecture of a subclass. But what we're going to do is we're going to try getting some of these things. And then what if you wanted to know their GPA? So I guess the only thing that we don't have now is a method that could return the value of that GPA variable, which is private. So in order to return the GPA, you would need to have a public method that will retrieve the value. So you could say return GPA. And then you could also have a setter method, right? So you could set a student's GPA to something, but this is sort of a setter method. This is sort of a setter method because this allows you to change one of the instance variables. It doesn't only allow you to just specify what it's going to be, but it would allow a student object, it would allow a particular student to improve their performance if that method is called on them. And you could call the method 3 times and then it will go up by 0.3. But that's essentially what you have going on here. So we can go ahead and test some of this functionality. The last thing we'll do is I want to demonstrate to you another use of the super method, but first, the super keyword. But first, let's go ahead and test out this functionality. Let's go into the person tester class, and I'm going to say student A equals new student. And then what we need to do is pass in arguments according to one of the constructors that we wrote. So one of the constructors accepted a string and then an int and then a double. Remember, it was their name and then their age and then their GPA. So then what you do is you can go ahead and get some of this functionality. So what if we wanted to get the name? Can we call the get name method? Because we didn't write this method in the student class. The answer is yes, because get name is inherited from person. So since student extends person, student gets everything that person had. So now what we're going to do is compile it and run the main method, and indeed we get the Renee, because according to the person class, if we call the get name method on a person object, it returns the name. And then when we called this constructor, when we said student A equals new student of Renee 16 2.82, it used this constructor that we wrote here at the top of student, where it assigns name to N, age to A, according to the superclasses constructor, which accepts a string and an int. And then it simply assigns the GPA to the third parameter. It assigns the GPA to whatever G is. So now essentially, if we go ahead, am I still sharing my screen? Sorry, I just want to make sure I'm still sharing my screen here. Okay, so hopefully you can see my screen share. But now what we can do, so that, yeah, that's basically how that works. And so it's able to access all the functionality. What if we wanted to print the student object? Well, it would just go ahead and run the toString method of the person class, because student extends person, so student gets to use person's toString method. So now if we go ahead and run it, it says Renee is 16 years old, because according to the toString method, we print the person's name and then is, and then their age, and then years old. So it gets all that functionality, and it gets the functionality that's unique to student. So if we go think about studying harder, right? If we think about studying harder, that means that the GPA goes up by 0.1. So we can go ahead and call that method and then retrieve the GPA, and hopefully it's 0.1 higher than we assigned it to when we created the student. So what we could do is we could say a.studyharder, call a void method on that object. And then if we go ahead and say a.getGPA, instead of seeing 2.82, we should see 2.92. And so now we go ahead and run the main method of the person tester class, and indeed we get the 2.92. So that would be an example of functionality that's accessible to a student object, but not to a person object, right? What if you said person B equals new person, just calling the default constructor, which we defined. Remember, with the default constructor, we just gave default values to both the name and the age. And then you could go ahead and say system.out.println of b.getGPA, but that would be a problem because it's going to go ahead and say, well, the person class doesn't have a GPA, okay? So the student can get the get name from person, but the person cannot get the get GPA from student because that's functionality that's unique to the subclass. The other thing I'll say is that you can also have multiple subclasses of a particular class. So you could have a doctor subclass over here. And what you would do is you would basically, it would work in the exact same way where you would say doctor extends person. And now this is a whole nother class that gets person's functionality, but you would have a different instance variable. So maybe you would keep track of what hospital they work at. And then you'd have your constructors. You could say string n, int a, and then you would say string h or something. And then you could call the superclasses constructor. You would call person's constructor assigns name to n and age to a. That's all that it does. And then you would say hospital equals h. And so that would just go ahead and return the hospital. And then you could say public string get hospital. So this would be an example of a method that's unique to the doctor class, and you would just return hospital. Okay, so now you can go ahead and go back to person tester, and you could create a doctor, and you could say Dr. D equals new doctor. Let's call him Dennis. We'll say he's 44 and he works at Mercy Hospital. Okay, so now you could go ahead and get that Mercy Hospital. You could say d.getHospital. This is a method that's unique to that subclass. So now if you go ahead and run the person tester method, that's where we wrote it, you get that Mercy Hospital there. The other thing, the last thing I'll say, I know we only have 2 minutes left, is that you can also go ahead and change the functionality of a superclass's method in the subclass. So here's what I mean by that. What the toString method of the person class does is it returns their name and then is and then age and then years old. But what we could also do in the student is we could concatenate the result of this toString method with another string which says and has a particular GPA. So here, let me show you what I mean by that. We're going to go into student and we're going to say public string toString. So we're going to create a toString method for the student in particular. We already have one for person, but now we can have a more specific one. What you're going to do is you're going to say return super.toString. If you call super dot and then one of the methods of your super class, what it does is it returns the functionality of that superclass. So it's going to return the result of the toString method from person. So it would say name and then is and then age and then years old. But then you can concatenate and you could say and has a, and then you could say GPA and then GPA. You can say GPA directly because we're in the same class as where that private variable was declared. So it's no issue to reference it directly. So now, if you go ahead and print out a student, you could go ahead and print out Renee here, and you would have that additional functionality. So now you go ahead and press compile, and you go ahead and run the tester class once I can finally find it. And it says Renee is 16 years old and has a 2.82 GPA. Because what happened is if you call super dot and then a particular method in your super class, it just returns what that method would return. So you just say super.toString and say, give me everything that the toString method from the superclass would have given me, but then concatenate it with this extra information. So if you try printing a student object, not only do you get the result of person's toString method, but you also get this in addition. And if you pass in a variable, I know that the toString method doesn't accept any inputs, But if you call a particular method of the superclass, you say super dot and then method, and you pass in an input, then it would just run the superclass's version of the method with that input. And so this is just a string, and we concatenate it on another string, so that student has its own string representation. So hopefully that's helpful, and we'll continue our conversation in the next video. From Umozo3, thanks for watching, and please subscribe.